Good morning, guys. So last time we discussed rational zeros theorem. Is that right? Okay. So now you remember the rational zeros theorem. So this one, right? A P over Q is a rational number written in lowest term, and a P over Q is a zero of function f, and f is a polynomial function with integer coefficients. Then P is a factor of the constant term, and Q is a factor of the leading coefficient. So let me review that, okay? So given P over Q is a rational number in a lowest term. This is a rational number in lowest term. Okay. And then P over Q is a zero. So P over Q is a zero of fx. So P over Q is a zero of fx, and fx is a polynomial function, right, with integer coefficients. Then what will happen? Then P is a factor of the constant term. P is a factor of the constant term, and Q is a factor of the leading coefficient. So this is the rational zeros theorem, okay? Rational zeros theorem. So P over Q is a rational number in a lowest term, right? And then P over Q is a zero of fx, and where fx is a polynomial function with integer coefficients, then P is a factor of the constant term, and Q is a factor of the leading coefficient. Does that make sense? So this is a rational zeros theorem. So now let's work with the example, okay? Yeah, look here. So if you look here, guys, we have a polynomial function fx equals to 6x to the power 4 plus 7x cubed minus 12x squared minus 3x plus 2. Right? And then you need to find this. What is the leading coefficient here? So what is the constant term? What is the constant term here? 2. And what is the leading coefficient?
6.
Yeah. The leading coefficient is 6. So you find the factors of constant term. Okay? So the factors of 2 are, you guys know that, right? What are the factors of 2? 1 is a factor of 2, right? And 2 is also a factor of 2, right? So, and then you have to take both positive and negative. So the factors of 2 are plus or minus 1, plus or minus 2. Make sense? And similarly, you need to find the factors of leading coefficient. So what are the factors of 6? Factors of 6 are?
1, 2, 3, 6.
Yes. So you said 1, 2, 3, 6. Right? But you need to take the negative also. So negative 1 is also a factor of what? 6. Negative 2, negative 3, negative 6. You see what I'm talking, right? So you have a plus or minus 1, plus or minus 2, right? Plus or minus 3, plus or minus 6. Now, if we divide the factors of constant term by the factors of leading coefficients, you divide this by these values. So because we need P over Q. But what is P here? P is a factor of the constant term. So you have a factor of the constant term is divided by factor of the leading coefficient. Is that right? So now, if you divide plus or minus 1 by plus or minus 1, you see you have a plus or minus 1 divided by plus or minus 1. Right? If you pick one positive 1 on the top and positive 1 on the bottom, so that will be 1 over 1, which is positive 1. Are you with me? Right? If you take positive 1 on the top and negative 1 on the bottom, so that will give you negative 1. Is that right? And what are the other possibilities? Pick negative 1 on the top and negative 1 on the bottom. So if you have a negative 1 on the top and negative 1 on the bottom, so that will give you positive 1. Is that right? Pick negative 1 on the top and positive 1 on the bottom, then what will you get? Negative 1 over positive 1, that will also be what? Negative 1. Are you with me? Right? So that means either you get positive 1 or what? Negative 1. So if you divide plus or minus 1 by plus or minus 1, you will get what? Plus or minus 1. That makes sense? So you'll have a plus or minus 1. If you divide plus or minus 1 by plus or minus 1, you'll get plus or minus 1. If you divide plus or minus 1 by plus or minus 2, you'll get plus or minus 1 over 2. Make sense? If you divide plus or minus 1 by plus or minus 3, you'll get plus or minus 1 over 3. If you divide plus or minus 1 by plus or minus 6, you'll get plus or minus 1 over 6. You see that, right? We divide plus or minus 1 by each factors of what? 6. That makes sense? Now let's divide plus or minus 2 by each factor of 6, okay? So plus or minus 2 divided by plus or minus 1 is plus or minus 2. Are you with me? Plus or minus 2 divided by plus or minus 1 is plus or minus 2. Plus or minus 2 divided by plus or minus 2. What would be that?
Plus or minus 1.
Yes, plus or minus 1. Plus or minus 2 divided by plus or minus, but you don't have to write the plus or minus 1 because you already listed plus or minus 1 here, right? So you don't have to write here. Make sense? Plus or minus 2 divided by plus or minus 3, plus or minus 2 over 3, and plus or minus 2 divided by plus or minus 6. You see, I'm saying like a plus or minus 2 divided by plus or minus 6 is, you know, the plus or minus 2 over 6 is lowest term. You need a what? Lowest term. which is 1 over 3. Plus or minus 1 over 3, you already have here. Did you see that? Now, these are possible rational zeros. Possible. Are you with me? Yeah. Because this is from the rational zeros theorem. You see, this P over Q, these are the P over Q, is that right? What is this? So these are the values of what? These are the values of Q. These are Q's. These are what? P's. Are you guys with me? Right? And then you see these are the values of P over Q. And if P over Q is a 0 of fx, if, right, these values are zeros of f, here these are the list of possible zeros. You know what I mean? So the zeros of this polynomial function is here. That makes sense? And now, so this is the answer for the part A. So list all possible rational zeros. You can rewrite them like this, you know, like you can write plus or minus 1, and then you can write down this plus or minus 2, and then plus or minus 1 over 2, plus or minus 1 over 3, plus or minus 1 over 6, plus or minus 2 over 3. So you got it, right? Does that make sense, guys? Yes? Yeah. So, you see that? So now in the part B, you have to find all rational zeros. So these are the possible rational zeros. So you have to find the rational zeros in part B. So find all rational zeros and factor fx into linear factors. So find all rational zeros. So now you have to use synthetic. Okay? So now first let's check whether 1 is a rational zero. Okay? So now you pick the value of k is 1 and use synthetic. So you know how to use the synthetic, right? The coefficient of variable in a decreasing order, right? Like what is the coefficient of x to the power 4? You list the coefficient of variables, right, in a decreasing order. So what is the coefficient of x to the power 4? You write down 6. What is the coefficient of x cubed? 7. What is the coefficient of x squared? Negative 12. What is the coefficient of x? Negative 3. And what is the constant term? 2. That makes sense? And then you bring it down. You see, I list all the coefficients. Is that right? And then you bring down the first coefficients. So this is 6, right? You multiply 1 and 6. What is 1 times 6? 6. You write down under here. You add them up. What is 7 plus 6? 13. And then you multiply 1 and 13. Put here. So negative 12 plus 13 is positive 1. You multiply 1 and 1. You have a 1 here. And this negative 3 plus 1 is negative 2. Is that right? Right? And then you have a 1 times negative 2 is negative 2. You got a 0 here. Is that right? So this is the remainder. Are you with me? So since f of 1 is 0 because the remainder is 0, right? So 1 is a rational 0. 1 is a rational 0. Makes sense? Now what is the quotient, guys? So if you want to find out the QX, so this QX is quotient, okay? So, and you guys know that the degree of quotient will be 1 less than the degree of dividend, right? What is the degree of dividend? 4, right? So the degree of quotient will be 1 less than 4. So now it will start with x cubed, and you'll have x squared term, you'll have x term, and you have what? Constant term. Is that right? Right? So what is your constant term? What is your constant term? -2. What is the coefficient of x? 1. So 1 times x is x. And what is the coefficient of x square? Positive 13. So 13x square. And what is the coefficient of x cubed? 6. So you have a 6x cubed. So now this is going to be the what? Quotient. See that? Right? Are you with me? You see that, right? Because the degree of dividend is 4. Degree of quotient will be what? 1 less than 4. Right? So that means 3. So this will be the coefficient of x cubed. So 6x cubed plus. This will be the coefficient. This 13 will be the coefficient of x square. 13x square plus 1 times x is x, and the constant term is what? -2. You got it, right? So now you have to repeat the same process for this. That makes sense? Are you guys with me? So you see, we got 0, right? And then if you use division algorithm, so if you use division algorithm, you see dividend, your dividend is 6x to the power 4 plus 7x cubed minus 12x square minus 3x plus 2. So dividend equal to divisor. Divisor is x minus 1. Is that right? Because 1 is a 0, right? 1 is a 0 of fx. You guys know that, right? X minus 1 is a divisor. We did that, right? So divisor times quotient plus remainder. That's the division. You remember the division algorithm, like if x minus k is if the polynomial fx is divided by x minus k, right? And then there exists a polynomial qx and a number r such that fx equal to x minus k times qx plus r. You remember we did that. So this is a division algorithm. So if you use this, in place of k you have a 1. So x minus 1 times your quotient is 6x cubed plus 13x square plus x minus 2 plus your remainder is 0. You remember you got a remainder 0, right? So now you can rewrite this into this form. If this remainder is 0, you have to write down. So fx equal to this. So fx equal to x minus 1 times 6x cubed plus 13x square plus x minus 2. That makes sense? So now similarly, you say you have to use the same rational zeros theorem to find the rational zeros of what? This. You see that? So, are you guys with me? So now repeat the same process. You see, for this one, the leading coefficient is 6. So it's pretty much here. You see that? And what is the constant term? The constant term is -2 or +2? Is that -2? Okay, -2. The constant term is -2. And the factors of -2 are same, ±1 and ±2. You see that? So now these are the possible zeros for this polynomial. Is that right? Are you with me? So we already tried for 1, so we don't have to do for 1. So now let's try for -1. Let's try, we did already for 1. We know the 1 is what? 0, right? And that's why x minus 1 is a factor. Now let's try for -1. If you try for -1, so you list the coefficients, okay? So you have a 6 here, so this is 13, is that right? And this is 1, and this is -2. Use synthetic, you bring it down, it is 6. -1 times 6 is -6. 13 minus 6 is 7, right? So -1 times 7 is -7. So 1 minus 7 is -6. And -1 times -6 is +6. Is that right? And what do you get here? 4. Now you see the remainder is 4. So remainder is 4 means f of -1. This is remainder. You see that? So now this -1 is not a 0. However, it is on the list of the possible zeros. Right? You see what I'm talking, right? So it is on the list of the possible zeros, but it is not a rational zero of this function, of this polynomial. Right? So now let's try for what? +2, okay? If you try for +2, you bring it down, 2 times 6, 12, right? 13 plus 12, what is 13 plus 12? 25, 2 times 25, 50, 1 plus 50, 51, 2 times 51, 102, so this is what? 100. You see that? Right? So this is remainder, right? Which is, if you consider this is gx or qx, whatever, you consider this polynomial as what? Qx, it doesn't matter. Or gx, okay. So this is g2, which is remainder. The remainder is not equal to 0. Right? So that means this is not a 0 of gx. This is not a 0. We are just using trial and error. You know what I mean? You just like a try. Did you get it? So now it did not work. So now let's try for -2. Right? So -2 times 6 is -12. What is 13 minus 12? 1. -2 times 1 is -2. Right? What is 1 minus 2? -1. -2 times -1, +2. You see that? 0. So that means, so this is the remainder, right? So g of -2 is 0. So you guys know, according to factor theorem, this x minus x plus 2 is a factor of what? Gx. You know the factor theorem, right? X minus k is a factor of fx if and only if f2, f of 2 equal to what? 0. Or f of k equal to 0. You see what I'm talking. So the factor theorem, So x minus k is a factor of f of x if and only if, biconditional, right? If and only if fk equal to 0. Now here, what happened? G of negative 2 equal to 0, is that right? So that means x minus negative 2. X minus negative 2, which is what? X plus 2, is that right? Right? X plus 2 is a factor of gx in this case. Did you get it? So now, and again, if you use division algorithm, remember, so in this synthetic division, your polynomial this is divided by x plus 2, is that right? So x plus 2 is a quotient, is that right? X plus 2. Your polynomial is divided by x plus 2, right? So by division algorithm, there exists a unique polynomial qx, which is the quotient, right? So what is the quotient here? You can write down the quotient qx. This is quotient, okay? Are you guys with me? So quotient equals to, and now you say the degree of dividend is 3. So the degree of quotient will be 1 less than 3, that is 2. Is that right? It will start with what? X squared term, and then it will have an x term and the constant term. What is the constant? Negative 1. And what is the coefficient of x? Plus 1. So this is plus 1 times x, which is x. And what is the coefficient of x squared? 6. Make sense? So now, if you use the division algorithm, your gx, it was 6x cubed plus 13x squared plus x minus 2. This is a dividend, right? So now, what is your divisor? X plus 2. X plus 2 times. What is your quotient? 6x squared plus x minus 1. 6x squared plus x minus 1 plus remainder, but the remainder is 0. You guys know that, right? Remainder is 0. Does that make sense? Now, your function fx, this fx, okay? So this one, look here, what will happen here? This fx is equal to x minus 1, and you plug in, like this, 6x cubed plus 13x squared plus x minus 2 is equal to what? X plus 2 times 6x squared plus x minus 1. Right? I can replace this by x plus 2 times 6x squared plus x minus 1. Does that make sense? Did you get it? So now, so you don't have to use rational zeros theorem here because this is a quadratic polynomial. You know how to factor quadratic polynomial, how to find the zero of quadratic polynomial, right? Just factor it, okay? So now if you look here, this 6 times negative 1 is negative 6. 6 times negative 1 is negative 6. You need to find, right, a pair of factors of negative 6 such that the sum is positive 1, which is coefficient of x. Is that right? So let us find the factors of negative 6 such that the sum is positive 1. What are they?
3 and negative 2.
Exactly, 3 and negative 2. So now, you see, let me factorize. I'm taking care of this, okay? 6x squared plus x minus 1. So it is going to be 6x squared plus, this is 3x minus 2x minus 1. Right? So now, you see, what can you factor out here? You can factor out 3x. Are you guys with me? Right? Right? You can factor out 3x. So, yes. So now this is 2x plus 1. And here, what can you factor out from here? Negative 2. Negative 1. Right? You can factor out negative 1. So it will be what? 2x plus 1. And this 2x plus 1 is common factor. You have a 2x plus 1. And this is what? 3x minus 1. So you see the factors of this are 2x plus 1 and 3x minus 1. Now your fx is completely factored into a what? Linear factors. Right? So now it's going to be x minus 1 times x plus 2 times, now these are, what are the factors of this? This, 2x plus 1 times what? 3x minus 1. Did I make sense here? Yes? Okay, now you need to find the what? All rational zeros. So what are the rational zeros? Negative 2 is the rational zeros. Is that right? Positive 1 is the rational zero. You know the zero means, right? A zero of a polynomial function fx is the value k such that fk equal to 0. That makes sense? So let me write down here. A zero of fx is the value k, such that, right, fk equal to 0. So now what makes this function 0? If I plug in 1, it is 0. So 1 is a 0. Is that right? We did that, right? If I plug in negative 2, f of negative 2, it will be 0. Is that right? Right? And what are the other zeros? Are you guys with me?
Positive, negative, half.
Yeah. Negative 1/2, right? So I'm just like saying, hey, look here. So you just put fx equal to 0 to find 0, okay? To find zeros. So you do that. So you have x minus 1 times x plus 2 times 2x plus 1 times 3x minus 1. Are you guys with me? This is equal to 0. Is that right? So now, if you set x minus 1 equal to 0, that will give you x equal to 1. So this is 1, 0. Is that right? And what is the another one? You set x plus 2 equal to 0. Are you guys with me? So that will give you x is equal to negative 2. This is another 0. You say 2x plus 1 equal to 0. So that will give you 2x equal to negative 1. So x equal to negative 1/2. This is another 0. So the last one is you set 3x minus 1 equal to 0. So that will be 3x equal to 1, right? And you divide both sides by 3. So x equal to what? 1 over 3. So what are the rational zeros? So the rational zeros are, right, all rational zeros are negative 1/2, negative 2, right, 1/3, and 1. Does that make sense? Right? And these are the factors. Okay. You see that? We did it, right? Okay, we got it. So this is the fundamental theorem of algebra. Every function defined by a polynomial of degree 1 or more has at least one complex zero. So this is a fundamental theorem of algebra. Every function defined by a polynomial of degree 1 or more has at least one complex 0. And the number of zeros theorem, a function defined by a polynomial of degree n has at most n distinct zeros. Okay, a function f, a function defined by a polynomial of degree n has at most n distinct zeros. Okay? So if you have a cubic polynomial, right, it can have at most 3 zeros, right? That makes sense? If you have a quadratic polynomial, degree 2, it can have at most 2 zeros, right? And if you have a degree 4, it can have at most 4. You see, it has exactly 4 zeros in this case, right? Exactly. How many zeros? 1, 2, 3, 4. Okay, so now let's solve this problem, okay? So find a polynomial function f(x) of degree 3. You find a polynomial function f(x) of degree 3, right? And the conditions are, and you satisfy the conditions, zeros of -1, 2, and 4, and then f of 1 equal to positive 3. Okay? So, hey, look here guys. So this is a polynomial function of degree, you have to find out a polynomial function of degree 3, right? And what are the zeros? -1, positive 2, and positive 4. Now, use the factor theorem. If -1 is a 0 of f of x, so what will be the factor? If -1 is a 0, right? So what will be the factor? Yes, x plus 1. Remember, if k, you need to know this, okay? If k is a 0 of f of x, this implies x minus k is a factor of f of x. Does that make sense? So now here, what you need to know is this -1 is a 0, right? So x plus 1 is a factor. Make sense? Right? 2 is a 0. So what will be the another factor? X minus 2. 4 is a 0. Exactly, x minus 4. And now you see the polynomial function will have a leading coefficient, right? Let's say a is the leading coefficient. That makes sense? Yeah. So now, are you guys with me? We need to find out the value of a, right? You see that, right? Because -1 is a 0. X minus -1, which is x plus 1 is a factor, right? 2 is a 0, x minus 2 is a factor. 4 is a 0, x minus 4 is a factor. And then the polynomial function will have the leading coefficient a, right? So let's use this condition, okay? So f of 1 equal to 3, so you know f of 1 equal to 3, right? But what is f of 1? You plug in x equal to 1, right? If you plug in 1, so this will be a times 1 plus 1, and this will be 1 minus 2, and this will be 1 minus 4. But you know f of 1 is equal to what? 3. Did you get it? Okay. So now let's do a little bit math here, okay? So a, what is 1 plus 1? 2. 1 minus 2? 1 minus 2? Negative 1. 1 minus 4? Negative 3 equals to 3. Right? Make sense? And now, hey, what is 2 times negative 1? Negative 2 times negative 3? 6, right?
Negative 2 times negative 3 is 6.
Yeah. So 6. 6a equal to what? 3. And how do you find the value of a? What is the value of a? 3 over 6. Right? And what is the lowest term? 1 over 2. So now you plug in back the value of a here. Okay. So now you plug in back the value of a. So now you'll have f of x equals to, your a is 1/2. So 1/2 times x plus 1 times x minus 2 times what? X minus 4. So this is the polynomial function. Did you get it? Yeah. Yeah. And then hey, by the way, if you wanna multiply, you can multiply this, okay? Like you see, so this is the factored form, right? So if you wanna multiply, let's say I wanna multiply this x plus 1 times x minus 2 first. I wanna multiply these two, and then whatever the product I got here, then I'll multiply that on by what? X minus 4. Make sense? Are you with me? Okay. So now let's use FOIL. What is x times x? X square, right? X times negative 2, negative 2x. Positive 1 times x. X. 1 times negative 2, negative 2. Right? And so it will be x square minus x minus 2. Right? And then you multiply this, x square minus x minus 2, you multiply this by what? X minus 4. Are you guys with me? Right? I did, you know, like I multiplied these two and got this. And then whatever I got here, the product of these two factor is this, and you multiply it by x minus 4. Good? So now, again use FOIL. X squared times x, x cubed, right? And x squared times negative 4, negative 4x squared. Negative x times x, negative x squared, right? Negative x times negative 4, positive 4x, right? And then negative 2 times x, negative 2x. Negative 2 times negative 4 is positive 8. Good? So what did you get? So that would be x cubed. You combine these two, so that is negative. What is negative 4x squared minus x squared? Negative 5x squared. What is 4x minus 2x? Yeah, plus 2x plus 8. So now you see this is going to be what? Fx equal to 1/2 parenthesis. When you multiply this and this, we got this, right? Right? So now x cubed minus 5x squared plus 2x plus 8, and you distribute 1 half, okay? So this is 1 half times x cubed over 2, and this is 5 over 2x squared, and this is 1 half times 2x is x, and 1 half times 8 is 4. So this is the answer. Make sense? Yeah. Are you guys with me? Good. So now, do you know the multiplicity? Multiplicity, like 0 of multiplicity 3. What does that mean? The multiplicity of 0 is the number of times 0 occurs. You know what I mean? Like for example, let's say, like here, you see, what did you get? I think we have a fx equal to, I erase that, it's 1 half times x plus 1 and x minus 2, x minus 4. Now you guys know that the negative 1 is a 0, is that right? 2 is a 0, is that right? 4 is a 0, right? So how many times negative 1 occurs here? How many times negative 1 repeat? Only one time. Is that right? So only one time. So that's why the negative 1 is a 0 of multiplicity 1. Did that make sense? Now here, same thing. So 2 is a 0, right? So how many times 2 occurs here? How many times 2 repeats? Only once. Is that right? So that's why this 2 is a 0 of multiplicity 1. Same thing here. This 4 is a 0 of multiplicity 1. So the multiplicity of 0 is the number of times 0 occurs in the polynomial function. Like let me give you another example. So let's say you have a function fx equal to x minus 2 squared times x plus 1 and x minus 3 to the power 3. Did you see that? Right? So now how many times these two are, you know the 2 is a 0, right? 2 is a 0, right? So how many times this 2 occurs? How many times? 2 times. You see what I'm talking? Right? How many times 2 occurs here? You know the 2 is a 0. Right? So the 2 occurs or 2 repeats twice. Is that right? So 2 is a 0 of multiplicity 3. Multiplicity. Multiplicity 2. I'm sorry. Okay. Did you get it? And now, you guys know negative 1 is a 0, right? But how many times negative 1 occurs? 1. So negative 1 is a 0 of multiplicity 1. Negative 1 is a 0 of multiplicity 1. Right? Right? So now 3 is a 0, right? So how many times 3 occurs here? 3. So 3 is a 0 of multiplicity 3. Got it? Okay. So now look here, guys. So you need to find a polynomial function of degree 3 with real coefficient that satisfies the given condition, okay? So the given condition is this. So the given condition is negative 2 is a 0 of multiplicity 3, and f of negative 1 equal to what? 4. Right? So now, hey, negative 2 is a 0 of multiplicity 3. So what does that mean? So your polynomial function will be equal to leading coefficient, which is a, right? Negative 2 is a 0 of multiplicity 3. So that means negative 2 occurs 3 times. Is that right? So now that will be, you'll have the factor will be x plus 2, x plus 2, and x plus 2. Make sense? Right? Did you get it? So now, fx equal to, you can write down this is same as what x plus 2 whole cube, because x plus 2 raised to the power 3, right? So negative 2 is a 0 of multiplicity 3. But you see that, guys, f of negative 1 is 4. So we use this to get the value of a. Right? So now you plug in negative 1. So f of negative 1 is a parenthesis. So this is negative 1 plus 2 raised to the power 3. So this is a. So what is negative 1 plus 2? 1, right? 1 raised to the power 3 is 1. So now this is a, but you see f of negative 1 is what? 4. Right? So what is the value of a? What is the value of a? 4, right? That makes sense? So you plug in 4 here. So your polynomial function is if you plug in 4 there, your polynomial function fx is 4 times x plus 2 whole cube. And if you wanna expand this, so this will be, I mean, like you do that, I'll just write down the answer. Okay, this is the x cubed plus 6x squared, 3a squared b plus 3ab squared. So 12. Hold on a second. This will be x cubed plus 6x squared plus this plus 8. So that will be 4x cubed plus 24x squared plus 48x plus 32. I think this is the final answer, this one. You see that, guys? Yeah, 4x cubed plus 24x squared plus 48x plus 32. Make sense? You know how to expand. You can expand this, right? X plus 2 times x plus 2 times x plus 2. You'll get this one. So this is the final answer. Okay. So now, properties of conjugates. You guys know the conjugate, right? You know the conjugates of the complex number? So look here, guys. So if a plus bi or ib, whatever, like a plus bi is a complex number, and when you multiply a plus bi with a minus bi, you multiply a plus bi and a minus bi, right? So what will happen? So you multiply a and a, it's going to be a square, right? So you multiply a times negative bi, so negative a bi. You multiply bi and a, it's going to be positive a bi. And you multiply positive bi and negative bi, so positive times negative and negative. So bi times bi, you know, the bi square. Does that make sense? Right? So now you see a square and this, you can cross them out, right? And now that is the bi parenthesis bi square. So this is b square I square. Agree? And so this is a square minus b square. What is I square? What is the value of I square? Yeah, the I is an imaginary number, right? So this is negative 1. And now it's going to be a square plus what? B square. Now look here. These two are the complex number, right? The product of these two complex number is a real number. This is what? Real. So that means these two are complex conjugates to each other. Right? So that means a plus bi and a minus bi, a plus bi and a minus bi are complex conjugates to each other, okay? They are complex conjugates to each other. They are complete conjugates. Now, so if a plus bi is a zero of polynomial function f of x, then the complex conjugates a minus bi is also a zero of polynomial function. You see what I'm talking? Yeah. So now, if you look here, this is what I am talking about. If f of x defines a polynomial function having only real coefficients and a plus bi is a zero of fx, right? So then its complex conjugate, a minus bi, is also a zero of f of x. Are you with me? So basically what I'm saying is if g equal to a plus bi, right? G equal to a plus bi is a zero of fx, polynomial function of fx, right? Where a and b are real numbers, where a and b are real numbers, right? Then what will happen? Then its conjugate, conjugate g bar equal to a minus bi is also a zero, is also a zero of f of x. So this is what the conjugate zeros theorem. Make sense, guys? So this is what? Conjugate zeros theorem. Good? Did you get it? Okay. Now, look here, find a polynomial function fx of least degree having only real coefficients and zeros 3 and 2 plus I. So you need to find a polynomial function fx of least degree having only real coefficients and zeros 3 and 2 plus I. So what are the zeros? 3 and 2 plus I, right? So you find a polynomial function f(x). Find a polynomial function f of x. Okay? And then what are the zeros? Zeros 3 and 2 plus I. So now guys, look here. So you are going to construct a polynomial function f of x, and you guys know the zeros, which is 3 and 2 plus I, right? So if 3 is a 0, then what will be the factor? X minus 3. Excellent. And this 2 plus I is a 0, what will be the factor? X minus? Yeah, this is 0, right?
So it's x minus 2 plus I?
Exactly, x minus parenthesis 2 plus I. That makes sense? Right? And then, you know the conjugate zeros theorem. It tells you, hey, if 2 plus I is a 0, then its conjugate. So what will be the conjugate of 2 plus I? What will be the conjugate of 2 plus I? 2 minus I is also what? 0. Is that right? Right? So it will be, if 2 minus I is a 0, then what will be the factor? X minus parenthesis 2 minus I. Are you guys with me? Now, the one thing is, hey, we don't have to worry about the leading coefficient here. You know why? Because if you put leading coefficient here, let's say A, you don't have any condition here that will help you to get the value of what? A. So we just consider the leading coefficient is 1. Make sense? So now you just like multiply this, okay? So now f of x equal to x minus 3. Let's simplify this. Let's distribute this negative. X, negative times positive 2 is negative 2. Negative times positive I is negative I. And this is x. Negative times positive 2 is negative 2. Negative times negative is positive I. Does that make sense? Okay. So now let's multiply this first, okay? So I want to take care of this. X minus 2 minus. So we have x minus 2 minus I, this, and multiplied by this. And this is x minus 2 plus I. Right? So now, hey, use the FOIL. What is x times x? X is square. Are you guys with me? X times x is x squared. What is x times negative 2? Negative 2x. Right? So what is x times positive I? xi or ix, whatever. That makes sense? Right? So now, negative 2. Okay, negative 2 times x, negative 2x. Negative 2 times negative 2, positive 4. Negative 2 times positive I, negative 2i. Okay? And now, this I, okay? I times x, negative xi. Negative I times negative 2, positive 2i. Negative I times positive I is negative I squared. Did you get it? So now, hey, this positive xi and negative xi, I can cross them out. Right? And this positive 2i and negative 2i, I can cross them out. Make sense? And then, let's simplify this, okay? So this is going to be x squared, negative 2x, you combine them. So this is negative 4x. This is 4 minus, what is this I square? This I square is negative 1, right? right? And so this is x squared minus 4x plus 4, and negative times negative positive 1. So x squared minus 4x plus, what is 4 plus 1? 5. Are you guys with me? Right? Okay. So now you see we multiplied this 2 and we got that one. So now fx equal to x minus 3 times. So in place of this, the product of these two equal to what? X squared minus 4x plus 5, right? Right? I can replace this by x squared minus 4x plus 5. Good. So now again you use FOIL, okay? So fx equal to x times x squared, x cubed, right? X times negative 4x squared, x times positive 5, 5x. Are you guys with me? So negative 3 times x squared, negative 3x squared, negative 3 times negative 4x, positive 12x, and negative 3 times positive 5 is negative 15. Good? So f of x equal to x cubed. Now let's combine, like this negative 4x squared and negative 3x squared. So x cubed minus 7x squared. And this positive 5x plus 12x. The plus what? 17x. And what is this? Minus 15. So this is the polynomial function. Make sense? You got it, guys? Did you get it? Good, good, good. Okay, so x cubed minus 7x squared plus, yeah, it's good. Okay, we did that. So, so this is a lot, like it's got a little sign. Look here. I don't think how many. So look here, guys. So how do you find, like all real zeros, right? So let's do this one. Okay. Can you read this? Find all zeros of fx. F of x equal to x to the power 4 minus 7x cubed plus 18x squared minus 22x plus 12. Given that 1 minus I is a 0. Right? So 1 minus I is a 0. Okay? So what is your polynomial function? Your fx is, let me write. Your fx is, what is your fx? X to the power 4 minus 7x cubed plus 18x squared minus 22x plus 12. So this is your polynomial, right? So now you need to, what do you know is, given that 1 minus I is a 0, what is given? 1 minus I is a 0. Right? So now you can use synthetic. And what you are supposed to do here, you have to find all zeros. Find all zeros of this function, okay? So 1 minus I is a 0. So write down 1 minus I here. I'm going to use synthetic, okay? 1 minus I is a 0, so you list all the coefficients, okay? So what is the coefficient of x to the power 4? 1, x cubed, negative 7, x squared, 18, x, negative 22, and constant term is what? 12. That makes sense? So now, 1 minus 7, 18, negative 20. Yeah. You bring down the first coefficient. So this is 1, okay? Right? 1 minus I times 1. 1 minus I. Right? Combine them. Negative 7 plus 1 minus I. What is that?
Negative 6 minus
Yes, negative 6 minus I. Multiply 1 minus I and negative 6 minus I. Okay? You multiply 1 minus I and negative 6 minus I. 1 minus I, you multiply 1 minus I and negative 6 minus I. Okay? So now 1 times negative 6, negative 6. Are you guys with me? And 1 times negative I, right? Negative I times negative 6, positive 6I. Negative I times negative I is positive I square. Good? So now this is negative 6. Negative I plus 6I plus 5I. And this I square is negative 1. Right? So negative 6 plus 5I, this positive times negative, negative 1. So what is negative 6 minus 1? Negative 7 plus 5I. That makes sense? So now you put here negative 7 plus 5I. And then you combine 18 minus 7 plus 5I. What is that?
11 plus 5.
Yes, 11 plus 5I. Now you need to multiply 1 minus I and 11 plus 5I. You multiply these two. Okay? So 1 minus I times 11 plus 5I. So 1 times 11 is 11, right? 1 times 5I is 5I. Is that right? Negative I times 11 is negative 11I. Negative I times positive 5I is negative 5I square. So this is 11. What is 5I minus 11I? Negative 6I, right? Minus 5. So this is I square is negative 1. It's going to be plus 5. Does that make sense? So now this is 16 minus 6I. Is that right? So now here you have a 16 minus 6I. And what is negative 12 plus 16? Negative 6 minus 6I. Are you guys with me? Right? And you multiply this. Okay, 1 minus I times what? Negative 6 minus 6I. What is that is? 1 times negative 6, negative 6. 1 times negative 6I, negative 6I. Negative I times positive 6, positive 6I. Negative I times negative 6I is positive 6I square. So these two cancel. You have a negative 6 plus 6 times negative 1. What is that? Yeah, negative 12. Is that right? Right? And this is negative 12. And what is this is? 0. That makes sense? Right? And now, so this is 1, 0. One of the 0. Are you with me? And then you see 1 minus I is a 0. Right? So what is that other 0? It's conjugate. 1 plus I, right? 1 plus I. You see that? Now you use the 1 plus I, use the same method, you will get a 0 here. Is that right? You see, I want to show you, look at the slides, okay? I want to show you here. You see that? Right? And use the synthetic again, you will get a 0. Right? And then you factor x squared minus 5x plus 6. Okay, guys, I want to stop here. I will see you next time, okay? Bye.